there's a lot of talk right now that instead of prompting your agents, you should be writing loops or defining graphs. Is that a way from companies to make us spend even more tokens? Or are those legit engineering concepts that we should understand? Even if you're not realizing it yet, I'm pretty sure you've been using graphs or loops for a very long time. But I do think that understanding what they are and when to apply them makes you a better engineer. So let's jump straight into that. A loop is pretty much a prompt with success criteria. In case of a prompt, you just tell the agent to do something once, it does it, and it delivers a result. If we have a loop though, you tell the agent to do something, the agent does it, and then the agent self-verifies if the condition is met. If the condition is not met, then the agent acts again and checks its work again until the condition is met, until we pass the criteria, and then the agent stops working. So essentially in a loop, we have a start criteria such as every 5 minutes or at the beginning of the month. Then we have a task that we want the agent to complete. And then we have the success criteria. Until the criteria is met, the agent doesn't stop the work. Let me give you an example of a loop that I run myself every month. At the end of the month, I need to collect invoices and send those to my accountant. And this is super annoying, but loops are very helpful here. I tell my agent at 30th of every month, this is my starting criteria. I tell it to collect invoices from my email and send those to my accountant. But because this is a sensitive task that deals with payments, I need to define a pretty strict success criteria. And the success criteria is check against my bank statements if the invoices match the bank statements. Maybe there is some invoice that is not in my bank statement, so it should not be forwarded to my accountant. Whenever my agents collect all the invoices, then it checks them against my bank statement and discards the one that are not relevant, and then it forwards them to my accountant. And this is basically a loop. I think the innovation here is about the success criteria. And based on this success criteria, we could have different types of loops, which are described in this engineering blog post from Anthropic. There are different types of loops, and the first type is turn-based loops. This is your normal loop where you prompt the agent, it gathers context, takes action, and verifies the work. And Cloud itself decides if the work is done or not. There isn't some super strict verification criteria in turn-based loops, and such a loop could essentially be expressed by a skill. And here's a very good example. Verify front-end change, and then we prompt the agent how to verify the front-end changes. And then here's the looping condition. If any step fails, fix the issue and rerun from step 1. Then we have goal-based loops where the agent doesn't decide itself based on some intangible criteria, such as check if the front-end is good, but we actually have a score here. The lighthouse score has to be 90 or above. The stop criteria in goal-based loops is when the goal is achieved, and we can trigger this loop in Cloud code by typing in /goal. When you define a success criteria, Cloud doesn't have to make a determination on what is good enough. We just give it a very specific goal, such as lighthouse score 90 or above. Then we have time-based loops. This is something that I'm doing with my accountant. It is triggered in a specified time interval or specific time of the month. And you can trigger them with /loop or /schedule. And an example here is that you should check my PRs every 5 minutes, address review comment, and fix failing CI. And then we have a proactive loop. One example is when a ticket comes into your system, the agent can autonomously pick the work, solve the ticket, and you can hand off as much control to your agent as you want. Now, those are loops, but what are graphs? Graphs is when you need to span multiple agents and orchestrate the work between them. It's essentially writing a map for the agent how to complete the work. And I said in the beginning of the video that you've probably been using graphs already, because this here is a graph. When you tell Cloud Code to span multiple sub-agents to complete different tasks in parallel, this is essentially a graph. You could have one agent span one sub-agent to search the web for front-end inspirations. You could have another agent at the same time implementing the backend and another agent implementing the test coverage. So this is the map how the work should be done. Those are dependencies between agents. And those, in this case, are 3 parallel agents. This is a graph. It's not more complicated than that. Of course, if you have some special workflow, this graph could be extremely big with a lot of dependencies between the nodes. And we should not be comparing graphs versus loops because every graph could contain loops and every loop could contain graphs. For example, this one node of searching the web could be a loop on its own if we define a success criteria for what it means to have a front-end inspiration. I could give you another workflow example, which is a graph. And in this case, this is a sequential graph of events we can have the agent first implement our code, then verify it, then advise if we should do something else, and then fix based on the advice that the agent has. Now, this is a sequential pipeline. It is not a parallel workflow, but it is still a graph and it's still a workflow. And if you look at this and you're thinking, it reminds me of something, it probably reminds you of dynamic workflows in Cloud Code. If we look at the documentation, orchestrate subagent at scale with dynamic workflows, you would know that dynamic workflow is a script that orchestrates dependencies between multiple agents. For example, here we have a workflow to audit every route handler for missing auth checks. And then we defined an agent to list every TypeScript file under routes. And then we have a pipeline that based on each file, we check it for authentication. You can ask Cloud to write the workflow by just asking for it or by setting effort to ultra code. Now here's a more complicated dynamic workflow from a project that I was working on, and it includes exactly the stages as I was drawing them: implement, verify, advise, and fix. And then there's a lot of code here to orchestrate the agents. And this is nothing new, that there's this company that has been around for a very long time. The company itself is called LangChain, but there's a library that is called LangGraph. It's a bit small here. It's pretty much a library that lets you define dependencies between agents. It's an old library. It's not something new. It's something that we've been using for a while, but I think it's still good to remind ourselves of these concepts and understand it more deeply. Now, to answer the last question, when to use loops versus graphs, as I said, those are complementary concepts, but if you want some intuitive explanation that makes those concepts a bit more clear, then if you have a repeating task until it's done, then this is essentially a loop with a single agent. But if you have complex workflows that you need to orchestrate, then this is a graph. And in a graph, we usually use multiple agents, so there is no much context pollution between them. If you implement this as a loop, then it probably would be a single agent, and this agent has to hold a lot of context into its context window. And at some point, it would probably start behaving weirdly. So that's why it makes a bit more sense to express this as graph of multiple agents that hand off context whenever they are done. This was all from my side for today. Loops and graphs engineering. Thanks a lot for watching. See you next time.